In the second part of the tangents and radii video, I just want to draw one more relationship for you, and that is the relationship of the segments outside of the circle. And what I want to do here is first let's clean up the window a little bit. It's a little busy with the grid and the axes. So let's just turn off the grid and turn off the axes, and that'll just give us a cleaner picture. Now what we're going to look at is we want to know if we find point F here. This is the intersection of the tangents, and you can't move point F because it comes from the tangent. The only way you can move point F is if you move point B up and down, then you can move point F, or you can move point C up and down. And I just want to drag this point E a little bit off the screen here because we won't be using it. Alright, so now what we're going to look for is we're going to see if there's a relationship between the two outside line segments right here. They look awfully congruent, don't they? No matter what I do with the tangents, if I drag the tangents back and forth, let me just move that circle a little lower, and if I just drag those tangent lines back and forth, it looks like those lines stay congruent. So let's find out for sure. So to do that, we'll create line segments on top of our tangents. So segment, click, click, and then over here. So now we have two new line segments. So let's just show those values. So if you go over here, one of them was G. So I'll just show the label for G. Not the label, actually I want the value. Object properties. Show value, and then I want the same thing for H. I think if you just click on the segment up here, there's a drop down box, you can just do value right there. So look at that, both of those are 9 right now, 9 units long, and so when you move B or C, which are the driving forces for the tangents, you'll notice that no matter what you do, those two line segments stay congruent. And so there we go. So you can see almost, if you bring it down a little bit, you can almost make a rhombus out of it, or even a square if you can get it close enough where all 4 are congruent, you get 4 right angles. That one's a little too big, so let's try to make it there. Oh, there it is. So that would give us the square there. Or you can make those segments longer and get more of a stretched out. You would actually get a kite in that situation. The kite has 2 congruent sides here and 2 congruent sides here, but then the lines are not parallel to one another. So you can get some nice quadrilateral shapes out of the circle and using 2 tangents. And the only time you're going to have a problem is when the tangents don't intersect at all. Like in this problem here, they're intersecting, but you can cause it if you make those 2 radii into a diameter. The tangents will never cross each other. The tangents will be parallel to one another. In that situation, the tangents will never cross, so you won't get those line segments. But at any other angle position, either below or above the circle, you're going to get those 2 segments to be congruent. And the final thing I wanted to do with this lesson is I wanted to draw your attention back to the tangent and the radius. Now we know they make 90-degree angles. Whenever a tangent and the radius, whenever they're connected, they're going to make a 90-degree angle. So if they're 90-degree angles, remember our work with perpendicular lines, we should be able to see the slopes. And so if you go here, here's the equation of the tangent. If you right click and put it into mx plus b form, both of those into mx plus b form, it's a little easier to read. So the green tangent has a slope of 4. So what that means is the radius should have the opposite reciprocal slope. Opposite would be positive 4, reciprocal would be 1/4. The A to B segment, the radius, should have a slope of 1/4. To find out, let's put the grid back on, and we can see it here. Put the axis on as well so you can see the numbers. So when you go from A, now remember this grid is counting by 2's, so it looks like we're going to go up halfway, 1, 2, let's see, 2, 4 would be here. So let me see here. I think it may have rounded it. Did it round it? Yes, I think these numbers may have been rounded. So let me go up to my rounding tool and put that on 3 decimal places. You're right, it was rounded, so that's why I couldn't get to 1/4 exactly. The slope is actually a little more. It's actually, in this problem, it's negative 4.5. But I think you can see here, if you go up 1, and then you're going to go over 4 and almost 5 units between. This is a 4 and this is a 6, so 5 would be halfway, this would be a little shorter. So it does look like it's opposite reciprocal slopes. So that's another way to confirm if you do have a tangent, because the slope of the tangent has to be the opposite reciprocal of the slope of the radius. So that's another test you can use. And that'll wrap it up for tangents and radii.